This will help you with the G8 standard, and coincidentally, it's also Chapter 8. So if you need more help, that's where you can look. This was all about right triangles, so using Pythagorean theorem. Anytime you know two sides of a right triangle, you can use Pythagorean theorem to find the third. So in a problem like this, if I know two sides, make sure that you're plugging, Pythagorean theorem is a squared plus b squared equals c squared. Make sure you're plugging those into the right place. So this x piece, that's my c. It's across from the 90. So when I set this up, I want to do 8 squared plus 7 squared equals, and I can say c squared or x squared, it doesn't really matter, it's just a variable. Okay? Square those, then add them, and then make sure you always take the square root at the end. Okay? Problem like this, they're giving you all the measurements and you have to figure out which one is a right triangle. You can't tell by looking. You need to do Pythagorean theorem. So if I go to, I just happen to know that this is the answer, but I will show you why. So if I take the legs and use Pythagorean theorem, I'm going to do 5 squared plus 12 squared. Okay, that's 25 plus 144, which adds up to 169. Then if I do c squared, I get 13 squared, which is also 169. So if you have all three numbers and you use Pythagorean theorem and you see the left side's equal to the right side, that means it's going to be a right triangle. So when you hear right triangle, you should really be thinking about Pythagorean theorem. We can also use special right triangles, and I know some of you don't like these, but the 45-45 is so easy. Please just take the time to memorize it. Make your life a lot easier. You can always use trig, I guess, if you don't want to. But here's a problem where a 45-45 would come in handy. So I know that I've got a right triangle here. This is a baseball diamond, which would actually just be a square. So this is 90, this is 90. I want to know how far it is from second base to home. Well, if these are the same, if you've got 90 and 90, that means that these base angles are the same. So that tells me right there it's going to be a 45-45. And your 45-45 template says that if your legs are the same, then the hypotenuse is just going to be x radical 2. So if I see that both of these legs are 90, that means the hypotenuse is 90 radical 2. Now if you refuse to memorize that, for whatever reason, you can always use Pythagorean theorem. I could just do 90 squared plus 90 squared equals c squared. And you'll get a decimal answer, but when you type all of these in, you'll see that it's the same as 90 radical 2. Okay, here's another 45-45. What is the value of z? Okay, so if this is 4 here, to start with what you know, if I see that this is 4, what else can I find from that? This leg has to also be 4. I could find that my hypotenuse is 4 radical 2 over here. But if this is a 45-45 as well, if this leg is 4, then this has to be 4, and z is also 4 radical 2. So I think it makes it a lot easier if you can just memorize that. The 30-60 is a little bit trickier. I think it's still pretty easy. I mean, the more you say it, the more you write it down, it's going to be a lot easier to memorize. And I think it's a lot easier to use this than to do trig problems, but it's up to you. So across from 30 is always x. Across from 60 is x radical 3. And the hypotenuse is 2x. So let's maybe look at some of these problems. Again, you can always just use trig if you don't want to memorize that. If a triangle is equilateral, that means that the angles are 60. Okay, so all of these are 60, which means that up here would have to be 30. So now I've got a 30-60 triangle. Now you could just use trig if you want. I'm just going to use the special right triangles because I think it's easier. What is the length in inches of AD? Well, all the sides are 10. Okay, so if this is 10, that's 2x. Half of that, which this makes sense if this whole thing is 5, this is acting as a perpendicular bisector. So this has to be 5, and the cross from 60 is just going to be 5 radical 3. Again, you could use trig if you wanted to. Or if you can even get the fact that this is 10 and 5, then I could use Pythagorean theorem from there. So you have a lot of options. I'm going to skip that one. Let's look at some trig just to go over that. So make sure you have SOHCAHTOA memorized. And let's look at this problem. So I know that one of the legs is 12, this angle is 70. I want to know the height of the building. First thing you want to do is label your pieces. So I've got opposite and, oh, actually I labeled that wrong. That would be adjacent because it's right next to the angle. And this is opposite. Okay, out of SOHCAHTOA, TOA would be tangent. So I'm going to say the tangent of 70 equals opposite, which is x, over adjacent. X is up high, multiply. Make sure that you have your calculator in degree mode. And I'm just going to take tangent 70, close my parentheses, times 12, and you get 32.96, which 33 would be the closest to that. Up here, don't let this confuse you. They're just telling you what the ratio is. If you actually type in tangent 70 on your calculator, this is what you get out. So if you didn't have a graphing calculator like we do, this would be helpful, but we don't need that. Let's see if there's anything else I want to go over. So if you hear right triangle, let's look at this problem. You're given 3 measurements, and a lot of people confuse, do they want me to figure out if it's just a triangle or is it a right triangle? And once you see if it's a right triangle, then you want to use Pythagorean theorem. If they want to know if it's just a triangle, that's when you add the two smallest, see if it's greater than the third. Pythagorean theorem. Okay, this is a 45-45, and we could easily, right off the bat, I know that it's 6 radical 2, but if you don't want to use that, let me show you how you could use trig to solve it. So again, just label your pieces. I've got opposite, and, oops, I said opposite, but I wrote A. Opposite over hypotenuse. So that would be sine. So I could say sine of 45 equals 6 over x. When x is down low, switch, so I'm going to switch these around and rewrite it as x equals 6 over sine 45. Type that in on your calculator. 6 divided by sine 45 is 8.48, approximately 8.5. You go through and type all these answer choices in. Obviously, it's not going to be F or J. If I type in 6 radical 2 and 6 radical 3, 6 radical 3 is about 10 something. 6 radical 2 is 8.5. So this is the correct answer, whether you're using trig. If you're going to just have that triangle memorized, you could even do Pythagorean theorem. Hopefully, if you notice that this is a 45-45, then these legs are going to both be 6, and you could do Pythagorean theorem from there. Okay, and just always label the picture. So they tell you that Q is 20 and S is 90. Make sure you label that. Okay, that's the huge thing in geometry, is drawing the pictures, using the pictures that are given to you, creating pictures from the information, labeling the picture. It's really the best way to do it. So, read the problem carefully. They want you to find RS. Anytime you have an angle and you have a side, then you want to use trig to find the other side. We also had inverse trig, so I can find one of those to do. Use inverse trig when you are looking for an angle. So I'm going to make up one of these real quick just to go over it. Let's say I know that this side is 50 and this side is 10, and I want to find this angle. First thing you do is you label your pieces. So I've got adjacent and hypotenuse, which would be cosine. The only thing you do differently is you press the second button. So I'm going to hit second cosine. It should be the one that looks like this, the cosine with the -1. And then I'm just going to type in 10 over 50. and that'll be your answer. I'm going to do that real quick. So second cosine, 10 divided by 50, is approximately 78.5 degrees. Okay, I hope that helps. That was the G8 material. You should now try the worksheet. Let me know if you have any questions, and try the test on iTest. Good luck.